Oh, I saw it. Then my wife got pregnant, and for some reason she wanted to. No, we had 3 kids by then, so kids were not going to kick this out.
I think I reset it.
What?
There was no time set on it.
Yeah, 30.
This is 30 minutes?
Yeah. Then you press play.
Then press play.
Look, it's a good culture to raise children because there's lots of stimulation. Well, yes, we didn't do that. We homeschooled.
Okay, so I would like to present the next speaker. So from now, should I start? Yeah? Okay, good. Well, so my talk today, the first talk, is about how we're going to manage scholarly literature that's all over the internet and related to our area of research using semantics. I will start my talk with a brief introduction into why we are going to solve the problem, what is the problem, what is the motivation behind this research. I'm going to cover a little bit of the background that we are going to need to understand the topic and the technologies that are used in my research. I will briefly talk about the design of the system that I have before I show you the application of it and conclude my talk. So the motivation behind my work is one of those things that you struggle, the problem you struggle every day, and at some point you're like, somebody has to fix this. So the motivation is that we have an abundance of publications in so many different areas that are dispersed across multiple repositories on the web that are ever growing. And then we as researchers, we have this problem, we start looking for this publication, we download them, and the next problem is that how we're going to manage them. So there are a lot of web-based or desktop applications that are doing mostly bibliographical management, which means you only have a few fields like the authors and titles and journals, and then you try to manage based on that. But most of these existing systems, they give you support in managing your bibliographical data, but not actual content of papers. So there is barely no content support in the area of literature management. So we need an environment that can encompass various activities of a researcher. So we need support in looking for literature, downloading literature, keeping them, and then maybe making notes about each literature, and then later on retrieve those. With this problem, we hypothesized that we can improve this knowledge management, this knowledge-intensive literature analysis using some novel cooperation between actual human and some artificial intelligent assistants that work collaboratively with human users. With this hypothesis, we envision a collaborative system, mainly a wiki-based solution, for semantic management of research literature that will feature a web-based information that will represent the knowledge that's encompassed in papers, and maybe give us some text mining support for automatically extracting those knowledge out of literature. So when I started looking for similar systems to our research, I found basically 2 or 3 types of systems. There are systems that are post-publication semantic analysis, which means the papers are already published, you downloaded them, and then you got to do something. You have to analyze them and extract the knowledge. Wiki papers and AcadWiki, because I think it comes from Academic Wiki, are 2 examples of this, which relies on human users to go on these wiki websites, and then they use semantic forms and some kind of a semantic markup. What they do is that humans actually read these papers, and they go to this website and they write reviews about it. And then there's a whole fight of whether the review is neutral and everything. A second type of applications are pre-publication semantic enrichment, which means you enrich your paper with semantics before you publish it. I'm not sure if you've heard of the SALT framework. So the SALT framework gives you some special LaTeX commands where you can actually mark up the hypothesis, the conclusion, the data set, the formulas, and everything in your LaTeX file. And then when you compile the PDF later, you can actually extract those knowledge out of the paper and then store it somewhere else. So these are the two types of existing applications. Our work is complementary to these efforts in that we are also looking for semantic analysis of papers, but we want to generate this metadata not by relying on humans, but by some novel collaboration between humans and some AI in the back end. We would like to transform the papers that are meant to be read by humans into queryable artifacts so machines can also use them. And the most important thing is that we still want to remain amenable to humans, because humans, when you want to extract the knowledge, you want the humans to be able to still read them, to make notes about them, to do the management that they like. So a big chunk of my research relies on techniques from the natural language processing domain. So NLP is a branch of artificial intelligence that uses techniques from AI and computational linguistics to process content that's written in a natural language, like English. Fortunately, a multitude of NLP techniques already exist, like name entity recognition, finding persons, organization, dates, and everything in text, doing quality assessment, finding spelling, grammatical, or other metrics that are good for readability, or maybe do some kind of a summarization of papers. So these techniques already exist. In addition to that, there are some NLP APIs or frameworks that are available for us to build reusable components and then compile them together to make NLP pipelines that do actual tasks. So you might have heard of OpenCalais by Reuters that you can use as a web service to find persons and locations. Another comprehensive one is the GATE framework. It's a robust open source framework that's been there for more than a decade now, and we use in our design. But the problem with these APIs is that most of the times when you want to use this, for example, the GATE API, you have to have some kind of a little bit of a knowledge in NLP, and you want to know exactly how you want to use it in your application. So that's some kind of a hindering issue when you want to integrate NLP into your own application. And a while back, we started looking at the concept of a framework called the Semantic System Framework, with the core idea that we take these NLP pipelines, we wrap them as a web service, and we publish it to the client. So we hide all the complexity of linguistics and all the APIs and everything that are specific to a special API or a framework from the point of view of the client. So you as a client, you need some kind of an NLP support, you just make a web service call. So in this architecture, you are on the client side. You can be, say, a word processor. You send your content to our semantic assistant server with maybe a bit of parameters to customize the runtime behavior, and the server can execute one or multiple NLP pipelines on your content and return the results to you. So this is some kind of a high-level overview of what semantic assistant does. So when we started working on the design of this, we looked into how researchers actually work, what tasks they have that actually can be supported or improved with some semantic technologies. During our studies, we extracted a number of requirements. From them, I actually extracted some of the most important ones. So first of all, our scientists, they need some kind of a centralized repository for the knowledge. So the system must provide the ability to store the data as well as any other artifacts that they generate, like notes, freestyle comments, by humans or any other tool that they use. The next requirement is that they need some kind of a text analysis support, because humans are a little bit slow, right, in reading papers. There's finite amount of time, but if we had some automatic text analysis support, that would have been really good. The next requirement is that we rarely use in isolation. We rarely work in isolation, and most of the papers are written in collaboration. So we need some kind of a collaborative environment. Based on these requirements, we made some design decisions. First of all, we decided that we're going to go for a wiki-based environment for the collaboration and revisioning of documents and content that we generate. We decided that we're going to use Semantic Media Wiki to represent the knowledge that we extract from papers. And we decided that we're going to use text mining pipelines to extract those knowledge from papers in an automatic way. This is the actual architecture. So here's the workflow. You are the user on your computer. You're interacting with the wiki that we designed called the Ziva Wiki. We're going to see it a little bit later, which has the Media Wiki engine and the Semantic Media Wiki installed on it. On your wiki, there is a client. There is an extension, which is the Ziva Fact extension, which is the client of the Semantic Assistant, which is the plugin that talks to the Semantic Assistant server. And here on the Semantic Assistant side, you have the server and you have a repository of languages, of the language services, like summarization, like quality assessment. What we're interested in this architecture is that we want to, when we're given a paper, we want to extract the knowledge in it, and we want to extract in particular two types of entities. Not only we're interested in extracting the structural entities, all the sections, all the bibliographical information, but we're also interested in extracting semantical or rhetorical entities. We are interested in automatically finding the conclusion of this paper, automatically finding the hypothesis in this paper, or the results, or the comparisons, the claims, the contributions of a paper. So the idea is that when you have your paper, you're going to analyze it and you're going to create RDF triples out of the knowledge that you extract, and you're going to store them into your database so you can later on do something useful with it, like, for example, query it. For this, we had this idea of having some semantic templates. Templates are going to take care of the look and feel of the results, as well as all the semantic properties that needs to be attached to each piece of knowledge that you extract from the paper. So each template not only tells you that there is a title, and the title has to be shown in the table and everything, but it's also attached to a has-title semantic relationship. And when you use this template into wiki pages and you save them, you have the RDF triples in the database. So this is the user interface of our Ziva wiki. Here you have the NLP, here you have the NLP interface. These are all the assistants that are available on the Semantic Assistant server that can help you with your task at hand, like extracting and claiming contribution, or doing some kind of quality assessment on the readability. And then it allows you to give the URL of a PDF that maybe you found somewhere on the web, and then a wiki page name so that the results can be written into. So you can choose one or multiple assistants to run on your paper, depending on the task at hand, and then you can start analyzing the paper. What happens in the background, so you as a user, you just wait for the results to come, but on the background, the Semantic Assistant server will get the content of the PDF, will run the NLP services one by one on your paper, will gather all the results and writes it back to your wiki. So when it's done, you get nicely formatted information extracted from your paper, like the bibliographical information. We call it the publication info sheet. So these are all extracted from the paper. It does not talk to any external API. It does not rely on any other external API. It just processes the content of the actual paper. In addition, so this is the structural entities that I talked about. The interesting part is where we automatically extract the claims and contributions. So we process the text, we look for comparative voice, we look for some trigger words, and we extract the sentences in a verbatim format. So the very important thing here is that we do not generate, we do not make a summary. We're just taking the sentences that have some rhetorical entities in it from the paper, and we show them in a nicely presentable format in the wiki. So that's good. We extracted a lot of information from the paper. We put them into the wiki. The next question is that what are they good for? So one example is that now that we transformed all the paper into some kind of a knowledge representation, we can start querying. For example, here I have a natural language question. So give me all the contributions of Bahar. You're in a research group. You want to know about a specific author. Maybe you're writing the literature review or something, and you want to know all the contribution of this specific author. and you have this natural language question. It's very easy to transform it into some kind of an inline query in Semantic Media Wiki. So you're talking about all the publications, which have the author of the person you're looking for, and you're only interested in getting the title and the contribution. If you didn't have the support of this wiki, it would have taken you a fair amount of time to go all over the paper, to go through your notes, get all the papers out, maybe read them again to find all the contributions. But here it's all automatic because they are already enriched with semantic metadata and you just need to query them. The advantages is that the tables we're going to generate from these results are always kept up to date by the system. Because every time you view the page, every time you're querying the database, you're always looking at the most up-to-date information. Plus, maybe I'm working on a paper that has the Bahar as the author, and maybe my colleague is also somewhere else. He's working on the wiki, and he also discovers the paper which Bahar is the author, and we both enrich the paper in the wiki. So when I'm doing the query, I can also discover a paper that was analyzed by someone else in the wiki and has me as the author. So this is an example of the output of this query. So for example, I can show you that this was the paper ID, the wiki page name in the system. I have the title and I have all the contributions. Well, when I look at this table, I can get a a simpler view of what's happening, and I can actually read the papers, I can compare the contributions, and I can get a better view in an easier way. So the main question in my research is that I want to know the concrete tasks during the research workflow that can be improved with various semantic techniques. What I showed you here in my Ziva system, so Ziva system is not a full-fledged commercial product ready to be sold to people. My wiki here is an empirical environment. It's just a platform for me to experiment with different services, with different NLP services, with different people, with different workflows in research to understand the actual concrete tasks that researchers need help with. So I introduced the Ziva wiki to you. What needs to be done is that we need to improve the semantic, improve the user interface, and maybe add more NLP services, while I interview more researchers about their workflow. And I can do, when I get to a good stage, I can start doing an extrinsic evaluation, have actual users use the system to see if it's actually effective. Does it help researchers, or is it just another overhead? So I have about 10 minutes that I would like to show you a live demo of how it works. So this is my Ziva system. I should probably mirror my screen. Okay, good. So this is my Ziva system, Semantic Media Wiki. What I can do is that, let's say I was browsing the web and I found this paper. It's 15 pages. I don't have time to read it. I just want the entities that I'm interested to be extracted automatically. What I can do is that I can just copy the URL and I can add it to my wiki for automatic analysis. So what I do is that I just paste the PDF and I give it a name. Let's say MobiViz, which is the conference. And here are all the available assistants that are currently available in my Semantic System server. I can read the title, the description. Let's say I'm interested in finding claims and contributions of this paper, and I would like to also know how good it was written. The nice thing about this is that because it's connected to the Semantic System, it's service-oriented. If I want to add or remove any services to my wiki, there's absolutely no modification to the wiki interface, nor to the Semantic System. I can also customize the runtime behavior of my NLP pipelines through setting some runtime parameters, or I can just call them through their default behavior. We want to see what's actually happening on the inside is that this is my gate framework, and these are pipelines being run on the paper, on the back end. So me as a user, I don't see anything. I'm just waiting on this page for the invocation to finish. both services are done. Now this is the page that was automatically generated. So all the information in this page are generated by the NLP pipelines from the contents of the actual paper. So NLP pipelines are not always perfect because we're always dealing with natural language. So I might want to actually fix something here. It's very easy. Let's say, for example, in the author, I also have the one, which is the affiliation in the paper. It was extracted verbatim, right? So I can just easily edit it. Or maybe I can add some comments later. And I can see the publication info sheet. I can see the claims and contributions extracted, like claiming that our design was a novel pattern and the contributions are from this paper. In addition, I can look at some scalar values like the readability metric of how good the paper was written. So this was generated by the second pipeline, the readability metrics pipeline. In addition, I can also have the ability to make maybe a review, to write a review about this paper, or if somebody else also writes a review about this paper, here's the place where we query all the reviews related to this paper. So it's perfectly suited collaborative environment. And I just wanted to, I also enabled the fact box on the bottom of the page, that just to show you that all the information that we extracted from the pipelines will also be available as an RDF document. So now we transformed our paper, a 15-page paper, within a few seconds to a queryable knowledge base. So that's most of it. I'll take questions.
Do these files have to be uploaded to your wiki first?
No.
So you can just pick any text file that you can find online, and it will then also be stored on your
We don't store the actual PDF. We only store the knowledge that we extracted. So if you notice, this is coming from our Semantic software. This is the PDF, but this is running on my local. And we don't really keep the PDF. We keep the link where it came from. So one question here is that what if the document you're trying to reach is, let's say, behind some kind of firewall or behind some kind of an institution. I haven't really counted for the design of that. But for now, this proof of concept just relies on the fact that if you can see the PDF here through your internet, I can also get it into the wiki. As long as the pipeline has access to that to the content of that PDF, it's fine. And we don't keep it in the wiki for legal purposes.
Okay, what kind of file formats can you process?
All the 5 formats that the GATE framework can process. So GATE comes with some kind of a scraper for HTML, for PDF, and other formats, but we're actually a little bit bounded by that.
Can you find this, is this extract every sentence that has a certain keyword in it?
Yeah, so what happens is that because we are on a service-oriented architecture is that whatever you want to do, we design a service for that. You put the service into the semantic assistant architecture, maybe I can just bring that up. And then using that, we just publish it to our wiki. So any service that's available through the semantic assistant is also available on the wiki. So this way you can also customize it. If you have a wiki or if you're dealing with papers that are from the biomedical domain, then you need some biomedical pipelines. So maybe I can bring the semantic system architecture. Yeah. So you have the repository of the description of these, and then you have your NLP subsystem. Here I have the indexer, the readability analysis. That can also include some specific pipeline that looks for specific words in a text. And that will be published to your wiki.
Just really cool. So that backend thing, that's also that's running on your server.
Yes.
And if you want to add rules and other pipelines and things, you have to do that, or is that a thing?
It's an open source framework. You can just download it and you run your own.
Oh, so you could point the Ziva wiki at any NLP
So any semantic system
backend.
server. Yeah.
I see.
Yeah. So for example, now the semantic assistant server is running on my laptop here.
Right.
Okay. And then the graphical user interface, which is the GATE front end. But you can also run your own Semantic Assistant. So the thing is that when you download the Semantic Assistant server, it comes with some toy pipelines, like
Right.
finding persons, very simple stuff. But then you can create your own pipeline, just put it in your Semantic Assistant server, you run it, and you point your Ziva to that Semantic Assistant server.
Right. And so Ziva just sort of queries the back end for, hey, what pipelines have you got? And says, okay, these are the
Yes.
pipelines you can run.
And whatever pipeline that's available in the Semantic Assistant is also available in the Ziva interface. So these three, these are queried with some kind of a top wall. It queries the Semantic Assistant server, which queries its own repository to see what files are available, what pipelines are available, and it says, here are the pipelines that are available. And the wiki shows it to you in the interface. Yes.
So how are your results organized? So is there a way that they are categorized and that users can browse through?
Categorized by their content or by the pipeline that actually generated them. Because for now, the way they're organized is what pipeline they generated the results. I can show you, like this one. This one. So each tab here,
Mm-hmm.
each tab here is based, well, the publication info sheet is always there because that's a bibliographical information. The claims and contributions, if you remember, I ran two pipelines. One was this one was this one.
Mm-hmm.
So for now, every time you run a new pipeline, we look for the tab if it exists, and we just update the results. If not, we just add it.
Okay, so you have 12,000 documents in there. So how do I find the document that I'm looking for if I'm not triggered by author or title of the document?
You're looking for semantic queries?
Yeah.
Yeah, so I have actually a page with some predefined semantic queries. So here I have all publications, querying by type. I have all contributions of a specific author. I have all publications based on some score. Let's say I want to find all the publications that are suitable for university students. I'm looking for a flash score around 30. So because those papers are already annotated, I'm just going to refresh the latest results. Because they're already annotated, I can just get them in this list.
Okay. Can you also sort on keywords in the content?
Yeah, so what I can do is that I can extend my pipeline to also generate the keywords or find the keywords that are in the paper, and then we're gonna have some keyword relations, and then we can query based on that.
Okay.
So it's very, very extensible,
Okay.
both from the NLP side and all the semantic relations side.
Please, I have a question concerning the natural language processing. So using this extension, can we process wiki pages and not external publications? For example, I have my paper using Semantic MediaWiki, for example, and then I would like to extract the relation between the...
Yeah, so it's that's actually possible, and I have already done the plugin and all the implementation of actually analyzing the wiki pages, one or multiple wiki pages. There's a tutorial this afternoon at 3 o'clock, and I'm going to cover all of it. The architecture that actually does that.
Can you speak about a bit about the readability metrics? Maybe it's outside the scope, but I'm curious about it.
So I put the readability metrics because, well, it was pretty simple calculations. There's some there are standards for it. There are a few metrics that counts in the number of words, the length of sentences, the number of acronyms and everything, and it generates some numbers, some scores. So I put it to show that you can, not only you can extract verbatim text from papers, but you can also generate some scalar values, and you can show graphs and everything. So I just followed the same rules for readability analysis. So there are a few, I can show you this one. There are a few standard ones like Flash and Kincaid and Fog Index and everything. So what we do is that we have the content of the paper, so I do the calculations and generate the scores. And I just write the scores back to the wiki. It's a toy pattern.
I've got more practical questions. Could you batch process a number of URLs?
It hasn't been designed in this user interface, but yes, it's possible because the Semantic Assistant can queue those for you before sending them to the pipeline. what happens is that in NLP you have the concept of a document, and then you have the concept of a corpus, which is a collection of documents, and you can run the pipeline on a whole corpus. Yeah, so come to the tutorial in the evening because we have it all.
So I'm curious, so say that I know a paper and your extraction pipeline put something as a contribution, and I know that maybe you got confused because the paper was describing the contribution of something it cited.
Mm-hmm.
So it would be nice to be able to fix that and say that's not a contribution, and edit
The claims and contributions, you can do so. There is an edit here on the right side, so you just edit and then you edit the wiki content.
and then
But you cannot teach the pipeline to not make the mistake again. That's not supported in our framework yet. But you can absolutely, you can change anything you want.
have you thought about wikifying some of the terms?
Sorry?
Wikifying some of the terms in the claim?
No, not yet. Because this was just a proof of concept for the whole workflow of NLP and literature management. But yeah, sure. Yeah.
Yeah, so again, I think that the whole workflow is quite compelling. I mean, having this, you go to a wiki, you give it a URL, it will work in the background and generate content for you. That sounds very nice. But I wonder from a research perspective, I mean, extracting authors from papers is obviously a solved problem. I mean, people would just they go to Google Scholar and you can query important papers of some author, but I'm sure that's not what your main interest is. So maybe can you say a bit about your research interest, what you see as a maybe also an NLP research challenge coming up from this book?
So exactly, I also agree. That's why I'm trying to emphasize that this is just some kind of an experimental platform for me to give it to researchers and tell them, okay, which NLP service do you like the best? Do you like the best? What services you wished you had? And then while I'm talking to these researchers, I can pinpoint that one or two or multiple problems that are really hurting them and that are hindering their workflow, and then I can drill deeper into how I can improve that using NLP or using some semantic technologies.
Well, I could give you some.
Sure.
So for Wikidata, we collect a lot of references. So far, they are often simple and not often directed to PDFs, but they are also directed to PDFs sometimes. And verifying all that content, of course, automatically would be a great advantage. And much more complicated, of course, it would be great if there would be any way to automatically verify that the reference given for a certain semantic claim actually supports the claim from the text. But that is a much harder problem, of course, because it's interesting to have the sentences that describe the contribution, but the real structure, the real content of the contribution, you still have no access to it, which is, of course, a very hard problem, the AI complete in general. But maybe if you knew that the claim that is made is that this particular statement holds and is already a semantic statement, then maybe there is a way to search inside a PDF for whether the statement is actually supported there.
Well, that reminds me of, have you heard of nano-publications, when you actually make triples about the facts and the problems, the facts in a sentence, and they're actually, they're directly citable, so you can cite a claim inside sentence 15 of paper 12. So that was one of the things, it's one of the research.
But anyway, if there's such a service that can do such things automatically, it could be of great interest for Wikidata. Maybe that's all.
Thank you.
Have you tried running your system with articles that are not as well formatted as an academic paper?
No, actually. I tried different style, like I tried the ACM, IEEE, 2-column, 1-column, and everything, but that doesn't really affect because the gate framework scrapes the text out of the paper. Most of the time, it does a really good job. So the content that I can produce is as good as the scraper of the gate for now. But for example, for the claim and contribution extraction, I rely on the fact that literature, the scientific literatures come with some kind of like the section names, the flow of the, like I'm expecting a title and I'm expecting authors, I'm expecting affiliations, but no, I really haven't got to that area. Question? All right, good about time?
Yeah, we're good.
Yeah, thank you.